Sometimes we run into functions that are more conveniently expressed as compositions. One such example is the function f of x equals sine squared of 5x. This function can also be thought as f of x equals p of q of r of x, wherein r of x equals 5x, q of x equals sine of x, and p of x equals x squared. I know that's quite the mouthful, but think of it like this. You have three machines set up here in sequence. First the r of x machine, then the q of x machine, then the p of x. This should be a p of x. So the r of x machine, the q of x machine, and the p of x machine. Where r of x scales whatever input you put in by 5. Q of x takes the sign of the input, and p of x squares the input. So let's trace the path of x through these three machines in sequence and see what happens to it. So we put x into the r of x machine, so x gets multiplied by 5 and spits out 5 of x. Now this 5 spits out 5x. Now this 5x enters the sine of x machine, and this sine of x machine is going to, or the q of x, which equals sine of x, this machine is going to take the sine of whatever we input. So it's going to take the sine of 5x and spit that out. So now we have the sine of 5x entering this p of x machine, which is going to square the input. So it's going to take in sine of 5x and output sine squared of 5x. This is precisely what I mean by p of q of r of x. So you apply r to x, then you apply q to the result, then you in turn apply p to the result of that. In order to evaluate the derivative of such a function, we're going to have to make use of a rule called a chain rule. So the chain rule tells us that if we have a function g of x that's differentiable at x and f of x that's differentiable at g of x, then the composition h of x, which is f compose g of x or f of g of x, is differentiable at x. And in particular, this composition, the derivative of this composition is h prime of x, and it is f prime of g of x times g prime of x. So what is this saying? The derivative of this composition is the derivative of the outer function evaluated at the inner function applied to x times the derivative of the inner function at x. And note that this chain rule can actually be applied many times. So if we wanted to say find the derivative of, let's say we wanted to find the derivative of a of b of c of x. Well, then we can just say, well, and let's call this function, we'll just keep it as is. This derivative is equal to, so d dx of a of b of c of x is equal to the derivative of the outermost function evaluated at the composition that's immediately interior to that. So that's going to be at b of c of x. Do I have the correct number of parentheses? I think I do. Times the derivative of b evaluated at c of x. Finally, times the derivative of c with respect to x. So let's go ahead and apply the chain rule to the example I'd initially mentioned at the beginning of the video. F of x equals sine squared of 5x. We want to find the derivative of that function. So we're first going to do the outermost function. Well, first we're going to rewrite this as the derivative of sine of 5x squared. Sometimes writing as sine squared of 5x makes it kind of difficult to see that the outermost function is actually something squared. So now we want to differentiate this outermost function, which is really x squared, but using the argument sine of 5x. So this would be, well, x is, instead of x, we'll have sine of 5x here. And the derivative of x squared is 2 times x, so 2 times sine of 5x, right? Okay, and then this is going to be multiplied by the derivative of sine of 5x. Well, that's going to be, the derivative of sine of x, but instead of x, we'll use the argument 5x. Derivative of sine is cosine, and instead of x, we will have 5x. And finally, we're going to multiply by the derivative of 5x with respect to x, and that's just 5. So finally we just get 10 times sine of 5x times cosine of 5x. And the chain rule can be initially tough to wrap your hands around, so don't be discouraged if you don't immediately get it. As you use it over and over again, it will become quite intuitive. But back to this example, this 10 sine of 5x cosine of 5x can actually be simplified further using the double angle identity for sine. Hopefully you remember that sine of 2x is equal to 2 times sine of x cosine of x. And here we just have the substitution where x is actually 5x. So this is the same thing as 5 times sine of 10x. And we'll be working a lot more examples of using the chain rule in future videos. Not only just in topics only pertaining to the chain rule, but in pretty much any other topic most of the other topics that we'll be covering in the future, we will be using the chain rule.